Hello everyone, hey, my name is Terry Nelms and I'm here to talk to you today about measuring and mitigating social engineering software download attacks. So modern malware infections typically occur via one of two methods. First is the drive-by download. So in this case, the user has vulnerable software in their system, typically the browser or a browser plugin such as Java or Flash. And as they browse the web, they come across malicious code that redirects them to an exploit kit that results in the exploit kit using the vulnerability to both download and install malware. And so this is an attack against the software itself. The other way machines get infected is through social engineering attacks. And so in this case, the user is browsing the web and they come across content that uses deception and persuasion techniques to convince the user to voluntarily download and install the malware. So in this case, it's an attack against the user and not the software. An example of a social engineering attack is fake AV. So in a fake AV attack, the user is typically browsing the web. They come across a malicious advertisement that tells them that their machine is infected with malware and that they need to download and install this tool to remove it. However, when they download and install this tool, they're actually installing malware, not actually installing a tool to remove malware. And so there's been a lot of work around drive-by downloads. And so there's been a lot of research both on ways to detect drive-by downloads and ways to mitigate their impact. However, there's been relatively little research done on social engineering. So in our research, we actually do a study of web-based social engineering downloads. And so for our study, we need to collect a lot of data, a lot of real-world social engineering downloads. So we deployed a collection agent on a large academic network for a period of 2 months. And this collection agent performed real-time deep packet inspection to reconstruct HTTP transactions. And we buffered these HTTP transactions in memory for all the users on the network. And we typically had around 5 to 10 minutes worth of HTTP traffic in the buffer, and it depended basically on the amount of load in the network at the time. And so once we observed an executable download, we basically we recorded both the actual executable download itself as well as all the network traffic that went to the user that's currently downloading the executable, and we saved that, all that traffic. And so the next step is that we actually retraced the web path. And so since we had the data for both the executable download as well as the HTTP transactions that occurred just prior to that download, we were able to reconstruct the click path followed by the user. And so the click path being some origin, such as a search engine, and then the search engine results, and then the user clicking through the results of the search engine and then hitting the page that actually had the deception persuasion techniques that convinced them to download the executable, and then finally the executable download itself. So in all, we collected almost 36,000 downloads from this network, and a little over 2,000 of these downloads were successful social engineering downloads. And by successful, I mean we actually saw the user download an executable. And so through extensive manual analysis and the reconstruction of the path, we were able to then examine these social engineering downloads. So today I'm going to talk to you about the categorization of these social engineering downloads and talk about the tactics used to trick users into downloading and installing these applications. And then we're going to measure some properties around the downloads. And then I'll end the talk with some discussion on how to detect social engineering download attacks. So let's start with the categorization system. And so an attacker that wants to use social engineering really needs to do two things. First, they need to gain the user's attention. And once the user's attention has been gained, they need to convince them that they want to go out and voluntarily download and install the software. And so I'm gonna show some examples and describe the different techniques here, and we'll start with gaining the user's attention. So a very common technique used to gain the user's attention is an advertisement. And so on the screen here is an example of an advertisement used to get the user's attention. And so this particular user performed a Google search, and their search terms were basically watch the latest episode of Scandal for free online. And so in the search results, they came across a link that eventually led them to this site. And so on this site, this is actually the episode of Scandal that they wanted to watch. However, the watch in HD and download now that you see overlaid on top of the video is actually not a part of the video. It's actually an advertisement that has been overlaid on top of the video. And so the user wanting to go watch the show ends up clicking on the advertisement and not on the video. And they end up downloading the executable that has Scandal and even the episode of Scandal's name in it, but it's a .exe. It's not a video. And so they end up installing software that they don't want and not watching the Scandal episode they wanted to. Another way attackers get the user's attention is through search. So in this case, the user goes to a search engine and they type Firefox download. And here are the results for the Firefox download. The first result is the opendownload.com. And the next result is to Mozilla.org. And of course, you want to download Firefox from Mozilla, but a lot of users in a hurry to download the browser end up just clicking on the first link. And it's the first link here because it's actually an advertisement. And so the advertisement is actually placed the opendownload.com link prior to Mozilla. And so the user clicking on opendownload.com goes to the website. They end up getting Firefox, but they also get some other programs they potentially do not want bundled with their Firefox download. The other way attackers gain the user's attention is through web posts. And so in this case, a user's browsing a forum, and they're looking for integrated Chinese 3rd edition level 1 part 1 answer key. And they come across this post that looks like it's a link for what they want. However, when they click on it, they end up downloading the executable and not a PDF, and the executable doesn't really contain the answer key, but contains software, again, that they probably do not want to install in their system. So those are the ways that social engineer attackers gain the user's attention. Next, I'll talk about, once the user's attention has been gained, the actual deception and persuasion techniques the attacker then uses to convince them to download and install the software. And we'll start with decoy. So in this example, the user goes out to a website that has cracked software and also key generators. And they do this search for StudyMinder Homework System Keygen. And so if you look at the very bottom of the screen, you'll notice that there's basically 0 results from this site for what they're looking for. However, what's in between the search keywords and the results of the site is an advertisement, a decoy advertisement. And the advertisement actually has the words that they used in their search in the link, as well as showing download speeds. And so in this case, the user clicks on this advertisement and goes and downloads the software that's not the keygen that they wanted, but software that they do not want to install. Another way people or attackers social engineer people is through repackaging. And so in the example I showed you before in the opendownload.com, where the user clicks on the open download link, they end up on this site, and so they're able to download Firefox from here, but Firefox comes bundled with some additional software that they probably don't want to install. Another technique is impersonation. So in this case, the user was browsing the web, and they come across this advertisement. And this advertisement has, the Java icons on it, the name Java, Sun Microsystems, and everything makes it appear to be a way to download Java. However, clicking on the link to download Java, you actually don't go to Sun's site. You're not downloading Java. You're downloading other software. So this is impersonation. So they're making their advertisement appear to be something the user knows, in this case, Java. Invent is another technique. And so in the case of an event, the user here was browsing the web, and they're shown an advertisement that's warning them that their Flash player is out of date. However, there's no code in the advertisement that checks to see if the user really has the version of the Flash player the user has installed. And so they're actually inventing a scenario that the user's Flash player is out of date. And when the user clicks on this, they actually don't download Flash player, but they end up downloading some other software. Another technique is alarm. And so alarm uses the fear of the user to convince them to download and install software. So in this case, users browsing the web, and they're shown an advertisement for an Ebola early warning system. And it says, "Are you safe from Ebola?" And so this early warning system says it'll keep you safe by letting you know when other people around you are getting infected. And so the user's scared of this, and so they click on it, download it, and install it, but they don't really get a good detection system from it. Next is entice. And so in this case, the user was on a web forum, and they find this really cool looking Minecraft X-ray mod. And so by the description here, it's really enticing to go and download this. However, clicking on the Minecraft X-ray mod link does not result in getting this mod. Instead, it results in software that you do not want to install on your system. And then lastly is comply. So in the comply case, the user was browsing the web, and they went to watch a video. And when they went to watch the video, they were prompted with this ad. And so it says, "Install media downloader in order to watch videos. Required." And so to motivate the user, right, that the user has to comply with the user believes he has to comply with this request in order to watch the video that he wants. So those are the different deception persuasion techniques as well as the techniques to gaining the user's attention that we observed in the social engineering downloads. Next, I'll talk about some measurements around these downloads. So one thing to notice is that typically a social engineering attack just doesn't use a single tactic. And so it just wouldn't use repackage. They'll typically use repackage plus entice to trick the user. And if we look at the popularity of the different combinations of techniques, the top three are responsible for almost 90% of the social engineering downloads we observe. And so repackage plus entice is number one at about 48.5%. And then we have invent, impersonate, alarm at 21.7%, and invent, impersonate, comply at 19.2%. So to give an example of repackage and entice, I'll go back to the Firefox download I was talking about earlier. And so we know it has a repackage piece, right? Because you're getting Firefox, but you're getting some additional software that you may not want. The entice piece comes in but by this Firefox review that you have here. And so they're really attempting to tell the user how cool Firefox is, why they should install it, as well as having the free download icon. And so that's an example of a repackage entice social engineering attack. Invent, impersonate, alarm. We'll look at the fake flash example again. And so if you remember, in this example, the user's prompted with warning, your flash player is outdated. It's invent because the software doesn't check if they have flash player and what version they have. It's impersonation because the ad's claiming to be flash player. And it's alarm because it's using the fear of the user's flash player being outdated and vulnerable to try to convince them to download and install the software. And then for invent, impersonate, comply, if we go back to that install media downloader in order to watch videos, it's an invention because in this case you don't really need to install the media downloader to watch the video. In fact, just closing the ad, you're able to watch the video immediately. Impersonation, because they're using icons and colors to appear to be similar to Flash, and they're pretending to be a media player that you need to watch the video. And then lastly, comply, because it says it is required in order for you to go forward to watch the video. So if we look deeper into the invent, impersonate, alarm, and invent, impersonate, comply classes and look at the type of software that they're using to distribute, we see that fake flash, is most popular in the alarm class at almost 70% of the downloads that we observed for social engineering in this class are telling you that your Flash player is out of date or something about your Flash player needs updating. Fake Java, which is very similar to the fake Flash attack, is next at 30%. However, what we didn't see much of is fake AV, and fake AV only made up about 1% of our observations in this class. Looking at the comply side, we see that fake player makes up about 80%, and so fake player is telling you, hey, you need to install this media player, or you need to install this codec to go and watch the video. The other 20% from the comply class was fake Flash, and so in this case they're telling you, you need to install the latest version of Flash in order to watch the video. All right, so if we move on then to the popularity of the social engineering tactics for gaining the user's attention, we can see that ads dominate gaining the user's attention. And so ads alone were responsible for almost 81% of the social engineering downloads we observed. And then search plus ad adds another 7.3%. So combined, this is almost 90% of the social engineering downloads we observed. The ads basically allow the attackers to easily publish their deception and persuasion techniques on sites that are already popular among the targeted victims. And it also limits the exposure because the social engineering ads are only targeted at users that have certain searches or keywords or user cookies. So you may think, well, if so much of these social engineering downloads are ads, why don't we just block any download that is the result of an ad chain? Well, the problem is that a significant percentage of the benign downloads are also ad-based. And so we found that 7% of all benign downloads we observed were the result of an advertisement. And since the benign downloads are much larger than the social engineering downloads, you basically have a 40% chance if an ad is on the web path that the download is benign. And so the most popular categories for benign downloads through advertisements were in the games and utilities. And then the most popular software we observed during this time was the Tryon Worlds game being downloaded through advertisement and then followed closely by Spotify. We also looked at the entire ad chain for these social engineering downloads. And specifically here, we're looking at the top 5 ad entry point domains. And so this is the actual first name or the first domain we observe on the ad chain. And so what we found is that for the comply and alarm classes, that the majority of downloads begin with a few low-tier ad networks shown here. These low-tier ad networks are known to serve adware and malware, whereas like the benign class and even the repackaged entice class, typically their advertisements start with top-tier ad networks. All right, so those are the measurements around the social engineering downloads that we observed, and now I'm going to talk a little bit about detecting these social engineering downloads. So this slide shows AV detections both on day 0 and on day 30. And so day 0 is the day the actual social engineering took place and the binary was downloaded. And if we look at that, we see event impersonate comply, less than 5% of the downloads were detected by AV on that day. For event impersonate alarm, less than 15%. And for repackage entice, less than 25%. And the AV that we used, we actually submitted these to Virus Total and used the results of the AV from there. And then on day 30, almost all of them then exceed 70% for AV detection. And so what this means is that the software being downloaded through these social engineering attacks are not being detected on day 0 by AV. And so we looked at building a classifier that could then detect these social engineering downloads. And so we came up with 2 separate classes of features. The first class are ad chain features, and the other one is download URL features. From the ad chain, the first thing we looked at is this ad driven? And so is there an ad on the web path itself that led to the download? And so it's a Boolean feature. And the intuition here is that only 7% of the benign downloads had ads, whereas almost 90% of the social engineering downloads had ads. We also looked at minimum ad domain age. And so we looked at all the domains on the ad path, and we measured, and we found the one that had the youngest age, and used it as a feature. And the reason behind that is because the ads that serve malicious software tend to be blacklisted, and so they're replaced with young domains. We also looked at maximum ad domain popularity. This feature looks at our historical classifications for both social engineering downloads as well as benign downloads, and finds like the popularity of the ad in those classes and uses that as a feature. And the idea here being, as I showed you before, there's often a small number of low-tier ad networks that are responsible for the majority of social engineering downloads. And then moving on to the download URL features, we looked at download domain age. And so this is the age of the download domain itself. And these also tend to be young if they're serving malicious files because they get blacklisted and they have to rotate out domains. And we also used download domain Alexa rank. And so what we found is that over 60% of the benign downloads came from had Alexa rankings of less than 100,000, whereas the majority of social engineering downloads, the domain rank was above 1 million. So we used those features to build a classifier, and we trained the classifier over the 2 months of study data that we had. And then we predicted across 2 months of data that we collected after our study. And our classifier is designed to be deployed in real time and be able to make classification predictions as executables are being downloaded. And so what we found is our classifier has a true positive rate of just over 91% with a false positive rate of 0.5%. All right, so in conclusion, I discussed our classification system and how attackers gain the user's attention, and then the deception and persuasion techniques they use to get the user to download and install malicious software. And I gave some examples of each of these. And then we looked at measurements to see the popularity of the different techniques. And we also performed some measurements that would allow us to detect attacks in the future. And then we designed a classifier, and we showed the accuracy of this classifier at detecting attacks such as this fake flash download shown here. And with that, I conclude my presentation, and please, if you have questions, ask.
Questions?
Hi, and thank you for that insightful research. However, I have some criticism.
Okay.
You scanned basically a whole university network for a longer period of time, and some of the examples you explained are at least borderline illegal. So did you consult an IRB or an ethics and research committee? And what did you do to preserve the privacy and protect the privacy of your participants?
Yeah, so we did go through an IRB approval process for this. And yeah, we kept these files on the server that they were collected, and they were encrypted and protected, and so no one could really have access to it. Yeah.
Okay. But you didn't clean any metadata or something?
So we'd remove cookies and things like that that would be, that would have the typical data that would be, important to a user, that would have PII type information.
Okay, thanks.
Yeah.
Mm-hmm.
Algus Perdisci Google. Sorry if I missed this early on, but how did you identify, given a binary, because as I recall, you basically started with a set of binaries and you decided that some subset of them were malicious. Did you have some prior classification of whether a binary was malicious to see whether you needed to track back its
Well, no. So, I mean, we go into details in this in the paper, but basically, we end up reconstructing the web path of everything, you know. And then we have some heuristics that allow us to remove things fairly easily, like updates, for example. And then for the set that remains, we did extensive manual analysis where we actually looked to see, is it a drive-by download, or if it was social engineering by actually looking at, you know, what the user clicked through to eventually download the executable. But the full details are in the paper.
Thanks.
So I was wondering, so did you study how effective these different tactics that the software developers are using are in attracting victims? Whether, for example, an alarm is more effective than whatever, a compliance message or something like that?
Yeah, I mean, that basically goes to the popularity that I showed during the presentation. That repackage entice is most popular. Invent, impersonate, alarm is next, followed by invent, impersonate, comply. And so that's the popularity of the techniques that we observe. But what you have to remember though is all these are successful social engineering, exactly, right? Yeah. Because that they click. I didn't have the cases where they didn't click on the executable download. So. Yeah.
Mm-hmm. Okay.
Yeah.
Related to that, I was wondering if you looked at cases where. Any cases where like sort of the download, you know, the ad was shown to people, and I guess you didn't know when your data set didn't have situations where like they got a warning or anything like that, whether there was any mechanisms that sort of prevented these things.
Yeah. So I didn't know if they were running software or anything that actually gave them a warning on the system. Because I only had visibility at the network level, and so if a warning went across the network, then I could see that, but I couldn't see if they had local software installed if they got a warning not to click on the link or not. But I didn't observe any over the network, you know, telling them not to click.
Right. Because I mean, I see people kind of. I feel like this is sort of it's not an indictment of the user, it's indictment of us, right? Like that this happens because it's totally, in most of these cases, it's totally reasonable things for users to be doing.
Agreed.
Right. So I would just.
Well, thank you.
Mm-hmm. Okay, so this concludes our session, and let's thank the speaker again.